Let the world outside dissolve into a soft and distant murmur. We are drifting now upon a silent, glittering river of stars. Tonight, we journey home to a place we've never truly seen from the outside, our own Milky Way Galaxy. Close your eyes and let the quiet darkness behind them become your vessel. There is no need for speed here, only a gentle letting go, a surrender to the cosmic tide. We begin with the grand architecture of our stellar island, its very shape a secret kept from us here on the inside. Astronomers piecing together light from 100 billion suns have sketched a portrait of our home. And it is not the perfect flat spiral you might imagine. Our galaxy is warped, beautifully, elegantly warped. Imagine a spinning disk of light, and now picture its edges gently lifted on one side and softly pulled down on the other, like a massive celestial vinyl record left too long in the warmth of a distant star. This gentle flowing contortion is thought to be the gravitational whisper of our neighbors, the large and small Magellanic Clouds, companion galaxies whose tidal pull has sculpted our own over countless eons. They pull and tug, and the Milky Way responds not with rigidity, but with a slow, graceful flex. It breathes, a silent cosmic inhalation and exhalation that takes hundreds of millions of years to complete. The stars at the very edge of our galaxy, they are riding this slow, colossal wave, rising and falling through the galactic plane on a scale that defies all earthly comparison. This imperfection is not a flaw. It is a signature of its life, a story of its interactions written in the very structure of its form, a reminder that even the most immense creations are shaped by the company they keep, and at the heart of this spinning, warped disk lies another surprise. For a long time, we pictured a simple spherical bulge of old stars at the center, a dense, glowing orb. But the evidence now points to something more structured, more dramatic. There is a bar, a vast, elongated structure of stars, gas, and dust, stretching an astonishing 27,000 light-years from end to end. It is not a solid object, of course, but a coherent pattern, a river of tens of billions of stars, all moving in elongated, resonant orbits that create this immense luminous spine. This bar acts like a great cosmic conduit, funneling interstellar gas and dust from the spiral arms inward toward the galactic core, feeding the very heart of the Milky Way. It is the galaxy's engine room, a place of immense gravitational influence, a stellar highway that dictates the flow and destiny of material across thousands of light years. Picture it not as a static feature, but as a shimmering, rotating axis of golden and amber light, a core of ancient suns that gives our galaxy its foundational strength and character. It is the heartwood of our celestial home, the central rhythm that organizes the chaotic dance of a billion suns, a testament to the elegant physics that underpins the cosmos. As we drift outwards from this luminous bar, we encounter the great spiral arms, the feature that gives our galaxy its iconic shape. But their motion is a deep and profound puzzle, a gentle paradox to ponder as you relax. If the Milky Way rotated like a solid wheel, the arms would wind themselves up so tightly that they would disappear in just a few rotations. And if the stars orbited like planets, with the inner stars moving much faster than the outer ones, the spiral pattern would also tear itself apart. But they don't. The spiral arms persist. This is because they aren't physical structures in the way a rope is. They are more like cosmic traffic jams. They are what scientists call density waves, areas where the fabric of space and the distribution of stars and gas are slightly more compressed. As stars and gas clouds orbit the galaxy, they drift into these slow-moving waves, linger for a while in the cosmic congestion, and then drift out the other side. While they are inside the wave, the compressed gas collapses to form brilliant, new blue-white stars,
which is why the spiral arms are so bright and beautiful. They are the stellar nurseries, the places of birth. The arms themselves are just the pattern, the wave, while the stars themselves are transient travelers passing through. It's a beautiful thought that the most brilliant features of our galaxy are not things, but places of passage, fleeting moments of stellar creation, illuminating a pattern that is itself as insubstantial as a wave upon the water. Now, consider the speed of this journey. Our own sun, carrying our Earth and all of us with it, is moving through the galaxy at a breathtaking velocity, somewhere around 220 kilometers per second. It is a speed so immense that if you were traveling that fast on Earth, you could circle the entire planet in just over 3 minutes. Yet, even at this blistering pace, it takes our solar system about 230 million years to complete a single orbit around the galactic center. This vast span of time is sometimes called a galactic year. The dinosaurs, for instance, emerged and disappeared within the span of a single galactic year. The entire history of humanity is but a flicker, a tiny fraction of a second in that cosmic orbit. And here is the deepest part of the mystery. You would expect that stars further out from the center would travel much slower, just as Neptune travels more slowly than Mercury. But they don't. For the most part, stars in the outer regions of the Milky Way are traveling at roughly the same incredible speed as our Sun. There isn't enough visible matter, enough stars, gas, and dust to create the gravity needed to hold on to these fast-moving outer stars. They should, by all accounts, be flung off into the intergalactic void. The fact that they aren't is the primary reason astronomers theorize the existence of something they call a halo of dark matter, an immense, invisible sphere of substance that surrounds our entire galaxy, holding it together with its unseen gravitational grip. We are held in an embrace we cannot see, tethered by a force that reveals itself only through the grace of the stars' impossible silent dance, a universe far more mysterious than we ever imagined. Let us drift deeper now into the living, breathing nature of this stellar island. For the Milky Way is not a solitary wanderer in the void. It is a dominant presence, a gravitational sovereign, and it grows by drawing others into its embrace. Our galaxy is in the slow, patient process of consuming one of its smaller neighbors, the Sagittarius dwarf spheroidal galaxy. This is not a violent collision, but a graceful, cosmic merger stretched over hundreds of millions of years. The smaller galaxy, caught in our gravitational tide, is being pulled apart, unraveled like a silken thread. Its stars are not destroyed, but are instead drawn out into long, looping ribbons of light, stellar streams that now wrap around the Milky Way, weaving themselves into the fabric of our own galactic home. We can see these rivers of orphaned stars arcing across our sky with powerful telescopes, a silent testament to a dance of cosmic union. It's a beautiful thought that the most brilliant features of our galaxy are not things, but places of passage, fleeting moments of stellar creation, illuminating a pattern that is itself as insubstantial as a wave upon the water. Now, consider the speed of this journey.
These stellar streams are the galaxy's ghosts, its memories. There are many of them, with names like the Orphan Stream, or the Styx Stream, or the River of the Underworld. Each one the faint, luminous echo of a globular cluster or a tiny galaxy that drifted too close and surrendered to our own. These ghostly processions of stars, numbering in the millions, trace the invisible pathways of gravity through the galactic halo. They are like celestial breadcrumbs, allowing astronomers to map the unseen,
to follow the gravitational contours of the dark matter that holds our galaxy together. By studying their paths, their gentle curves and twists, we can weigh the very galaxy we live in. We are surrounded by the faint, shimmering remnants of worlds that were. Their light a quiet song of a past that is now forever a part of our present. Even the end of a world can be a thing of beauty, its legacy a silver thread woven into the grand celestial tapestry. And just as the galaxy draws material in from the outside, it also circulates it from within in a vast, breathtaking cycle. Imagine a cosmic fountain. Deep within the galactic disk, when massive stars reach the end of their lives, they erupt in brilliant supernovas, explosions of unimaginable power. These blasts blow enormous bubbles of superheated gas, enriched with heavy elements forged in the hearts of those dying stars. This hot, buoyant gas doesn't stay in the disk, it rises, soaring tens of thousands of light years upwards, out of the galactic plane and into the vast, diffuse halo. There, far from the heat and chaos of the stellar nurseries, the gas slowly cools over millions of years, condensing like cosmic dew. Eventually, gravity reclaims it, and it begins to fall, drifting back down onto the galactic disk like a slow, nourishing rain. This gentle metallic rain seeds the interstellar clouds with the raw materials needed for the next generation of stars and planets, and perhaps even life. Our galaxy breathes a slow, rhythmic cycle of explosive exhalation and gentle, life-giving inhalation, a perfect self-sustaining engine of cosmic renewal. And while the vacuum of space carries no sound in the way we know it, our galaxy is far from silent. It hums with a symphony of invisible energies, a chorus of radio waves that astronomers can translate into sound. If your ears could hear in radio frequencies, the sky would be a place of incredible noise and music. You would hear the frantic, rhythmic ticking of pulsars, collapsed stellar cores spinning hundreds of times a second, sweeping beams of energy past us like cosmic lighthouses. You would hear the deep, steady hiss of the leftover warmth from the universe's earliest moments, a constant, gentle static from every direction. The great nebulae, where stars are being born, would murmur with the shifting of charged particles and magnetic fields. Scientists can assign pitch and tone to these signals, a process called sonification, creating hauntingly beautiful soundscapes from the data. They allow us to listen to the heartbeat of a black hole, the lullaby of a stellar nursery, the percussive rhythm of a neutron star. It is a hidden layer of reality, a song of creation being sung in a language of light and magnetism, a universe that reveals its deepest secrets not just to our eyes, but to our waiting ears. And for all this activity, this vibrant, dynamic life, what is the overall color of our home? When you blend the light of 100 billion stars, the fierce blue-white of the young and hot, the steady yellow-orange of suns like our own, and the deep, cool red of ancient giants, what shade do you get? Astronomers have painstakingly calculated this, averaging all the light we can see. The result is surprisingly gentle, surprisingly soft. The integrated color of the Milky Way is a hue very close to that of fresh snow seen in the hour just after sunrise or just before sunset. A soft, creamy white with just the faintest blush of gold and peach. It is not the violet, saturated palette of high-contrast photographs, but a peaceful, ethereal glow, the light of a quiet spring morning. Our cosmic home, a place of such immense power and scale, is ultimately painted in the most delicate and comforting light imaginable, a soft glow to light your path to dreams. Let us now turn our attention from what can be seen to the invisible forces that give our galaxy its structure and its spirit. Woven throughout the entire spiral disk, extending far above and below it into the halo,
is a vast and complex magnetic field. It is utterly invisible to our eyes, yet it is as fundamental to the galaxy as gravity itself. Imagine infinitesimally fine filaments of magnetic force, twisted and braided into colossal ropes, draping themselves along the spiral arms, swirling around the galactic center, a shimmering, unseen web that permeates everything. This field is weak by earthly standards, but over its immense scale, its influence is profound. It acts as a cosmic shepherd, guiding the flow of charged particles, containing the hot gas blown out by stars, and helping to channel matter into the dense clouds where new suns will one day ignite. It is the galaxy's nervous system, a silent, energetic architecture that holds chaos at bay and gives shape to the void. It is the unseen hand that sculpts the clouds, the quiet order that underpins the brilliant display of light.
And traveling along these invisible magnetic highways are the galaxy's messengers, cosmic rays. These are not rays of light at all, but actual particles, protons, atomic nuclei, accelerated to almost the speed of light by some of the most violent events in the universe, like the supernova explosions of giant stars. They are the fastest things in the galaxy with mass. They rain down upon everything, a constant, silent, energetic shower. Their journey is not a straight line, for they are charged, and so they are bent and deflected by the galactic magnetic field, forced to spiral along its lines of force in a journey that can last for millions of years. A single cosmic ray particle, born in the heart of an exploding star on one side of the galaxy, may wander for 10 million years, corkscrewing through interstellar space, before finally arriving here in our small corner of the cosmos. Their immense energy whispers stories of cataclysm and stellar death from 100,000 light-years away. They are the galaxy's memories of fire, ancient embers from stellar forges delivered on a magnetic wind across unimaginable gulfs of time. Let us now drift far away from the bright flat plane of the galaxy, out into the vast spherical volume that surrounds it, the halo. Here, the stars are few and far between, ancient, solitary wanderers. But scattered throughout this immense darkness are treasures, the globular clusters. These are breathtaking spheres of stars, hundreds of thousands, sometimes millions of ancient golden suns, all bound together by their own gravity into a single dazzling swarm. There are about 150 of them orbiting the Milky Way, and they are profoundly old. They are like cosmic fossils, relics from the very formation of our galaxy more than 12 billion years ago. Unlike the stars in the disk, they do not orbit in a neat, orderly plane. They follow their own eccentric plunging paths, swooping high above the galaxy, then diving straight through the crowded disk and out the other side. Their orbits chaotic and individual, like a swarm of ancient glittering bees around a central flower. Each one is a time capsule, a city of primordial stars carrying the faint, pure light of the universe's dawn. And while most stars are bound by the galaxy's immense gravitational embrace, a few are destined to leave it forever. Scattered throughout the galaxy are what astronomers call hypervelocity stars. These are suns moving at such incredible speeds, over 1 million miles per hour, that the Milky Way's gravity can no longer hold on to them. They are on escape trajectories, being flung out of the galaxy entirely to spend the rest of eternity wandering alone in the vast dark emptiness between the galaxies. The leading theory for their existence involves a gravitational slingshot of immense power. When a binary star system, two stars orbiting each other, strays too close to the supermassive black hole at the galactic center, the encounter can be catastrophic. One star is captured by the black hole, its orbit tightened, while its companion is violently ejected, shot away at a truly astonishing speed. For every star we see being cast out, another has been captured by the darkness at the heart of our home. It is a stark and beautiful testament to the power that lies at the galaxy's core, a power that can both bind and release, creating solitary wanderers from the heart of the cosmic crowd. There is another population of stars whose story is told not in speed, but in chemistry. In the thick disk of our galaxy, a region slightly older and more puffed up than the thin disk where our sun resides, there is a curious division. There are stars that are rich in what astronomers call alpha elements, things like oxygen, magnesium, and silicon, and another population that is poor in them. This chemical duality suggests our galaxy had a dramatic and eventful youth. It points to a period of intense, rapid star formation very early on, which produced the alpha-rich stars, followed by a major collision. The evidence suggests that around 10 billion years ago, a large dwarf galaxy, which astronomers have named Gaia Enceladus, slammed into the young Milky Way. This colossal merger was a formative event. It churned up the existing stars, triggered a new wave of star formation that created the alpha-poor population, and ultimately puffed up the disk into the thicker shape we see today. The echoes of this ancient crash are written in the chemical composition of the stars themselves. Every star is a history book, its light a page of text telling a story of creation, of collision, and of the grand and violent assembly of the home we now call our own. Let us now turn our gaze now toward the substance between the stars, the interstellar medium. It is not an empty void, but a delicate, complex ecology of gas and dust, a tenuous atmosphere for the entire galaxy. And within this medium exist structures of astonishing scale and fragility, the galactic filaments. These are enormous thread-like structures of magnetized gas, some stretching for hundreds of light years, yet they are incredibly narrow, sometimes only a fraction of a light year wide. They are like cosmic harp strings, glowing faintly in radio waves, aligned with the grand magnetic field of the galaxy. Their origins are a deep puzzle. Some may be the illuminated edges of vast colliding interstellar bubbles. Others might be the trails left by fast-moving star clusters plowing through the gas. They are utterly invisible to our eyes, yet they trace the hidden currents and tensions within the galactic fabric. A delicate, luminous calligraphy written on the darkness. They are the whispers of the void made visible, the faint lines of force that reveal the unseen structure of our cosmic ocean.
Within this same interstellar medium, there are pockets of profound cold and darkness, the Boak globules. These are small, intensely dense, and frigid clouds of gas and dust, so opaque that they completely block out the light from any stars behind them, appearing as inky black patches against the rich starry backdrop of the Milky Way. They're cosmic cocoons. Inside these silent, cold hearts, where temperatures can drop to just a few degrees above absolute zero, gravity is slowly, inexorably pulling the material together. They are the very earliest stages of star formation, the quietest, darkest places in the galaxy, pregnant with the possibility of light. In the deep stillness of a Boak globule, a future sun is gathering its strength. A future solar system is waiting to be born from a collapsing cloud of primordial material. The darkness is not an ending, it is a womb. It is from the deepest silence and the most profound blackness that the most brilliant light will eventually emerge. And as light travels from these nascent stars or from distant ones, it doesn't always have a clear path. The dust between the stars has a peculiar effect. It scatters blue light more effectively than red light. This is the same principle that makes our own sky blue and our sunsets red. On a galactic scale, this means that the farther away a star is, the more of its blue light is scattered away from our line of sight, making it appear redder than it truly is. This phenomenon, known as interstellar reddening, is like a cosmic fog.
It can trick astronomers into thinking a star is cooler and older than it actually is. They must carefully measure this reddening effect and subtract it to see the star's true color, its true nature. The galaxy has a veil, a soft, dusty haze that gently shifts the color of everything within it, a constant reminder that our view of the universe is always filtered, always mediated by the subtle substance that fills the space between the stars. Every ray of starlight is a traveler that has endured a long journey, its color telling not only of its own nature, but of the long, dusty road it has traveled to reach us. Let us now consider the very edges of our galaxy, the far outer rim. Here, the disk of stars doesn't just end, it flares. Like the gentle upward curve of a bell, the stellar disk of the Milky Way becomes thicker at its outermost edges. The stars here are more spread out vertically, forming a more puffed up, diffuse structure. More curiously still, this flared edge is populated by stars that are surprisingly young. One would expect the oldest, most ancient stars to populate the farthest reaches, but instead, we find stellar nurseries and clusters of bright blue, youthful suns. It is thought that perhaps the gentle infall of pristine gas from the intergalactic medium, a constant, slow drizzle from the intergalactic medium, provides the fresh fuel needed for the surprising, ongoing starbirth at the very frontier of our stellar island. The galaxy is not a static, finished object. It is still growing, still being built at its very edges. Even in the most remote and lonely provinces of our home, the fires of creation are still being lit, a sign of quiet, persistent life at the edge of the known. And surrounding this entire structure, the disk, the bar, the bulge, and the stellar halo, is another, even larger and more mysterious component, a vast, hot gaseous corona. This is an immense, tenuous sphere of multi-million degrees gas that extends hundreds of thousands of light years in every direction, dwarfing the visible part of the galaxy. It is so sparse and so hot that it is incredibly difficult to detect, shining only faintly in high-energy X-rays. This colossal atmosphere contains a tremendous amount of mass, perhaps as much as all the stars in the Milky Way combined. It is the galaxy's reservoir, the repository for the material blown out by supernovae, and the first point of contact for gas being drawn in from the outside. It is a place of constant cycling, a cosmic buffer zone where the galaxy's past and future mingle in a fiery, invisible haze. We are living inside this immense, hot bubble, and we are only just beginning to understand its scale and its purpose. We are held within a sphere of fire we cannot feel, a protective, energetic layer that mediates our home's relationship with the vast, empty universe beyond.
Let us journey now to the very center, the heart of it all, a place of profound mystery and power. At the core of the Milky Way lies Sagittarius A star, a supermassive black hole. Its mass is equivalent to that of more than 4 million suns, all compressed into a region smaller than the orbit of Mercury. Yet for all its immense gravitational power, it is surprisingly quiet. Many other galaxies have fusely active cores known as quasars that outshine the entire galaxy of stars around them. Ours, by contrast, is a slumbering giant. It is not dormant. We can see flares of X-rays and infrared light as stray gas clouds and unfortunate stars venture too close and are torn apart by its tidal forces before being consumed. But its meals are infrequent and small. It is in a state of cosmic fasting, a sleeping titan. The reasons for its relative tranquility are a subject of intense study. Perhaps the great central bar is not as efficient at funneling fuel to the very center as we thought. Or perhaps vast magnetic fields are holding the gas at bay. It is a place of infinite density and near infinite quiet, a sleeping heart whose dreams are the faint, flickering embers of consumed stars. And orbiting this sleeping giant is a collection of truly baffling objects. Very close to Sagittarius A star, there is a cluster of massive, young, brilliant blue stars. This is a profound paradox. The intense gravitational environment so close to a supermassive black hole should be incredibly hostile to star formation. The tidal forces should tear any collapsing cloud of gas apart long before it could ever form a star. Yet, there they are, a swarm of youthful suns in a place where they should not exist. One leading hypothesis suggests they were not born there, but formed farther out, perhaps as part of a dense star cluster, which then migrated inward and was captured by the black hole's gravity. Or perhaps they formed in a dense accretion disk that once surrounded the black hole, a temporary cosmic womb in the most violent place imaginable. Whatever their origin, their existence is a testament to the universe's ability to create beauty and order in the most unlikely of places. They are impossible children, brilliant points of light born in defiance of all cosmic logic, circling a heart of perfect darkness. As we look toward this galactic center, our view is obscured by vast dark curtains of interstellar dust, the Great Rift. This is not an empty patch in the sky, but a series of immense, overlapping molecular clouds that lie between us and the galactic core. For more perspective, on Earth, it appears as a dark, irregular lane that splits the bright Milky Band of the galaxy in two, stretching from the constellation Cygnus to Sagittarius. To ancient cultures, it was a river in the sky, a celestial road, or the spine of a great cosmic animal. To astronomers, it is a region of intense star formation, a place where the densest, coldest gas in the galaxy resides, shielding its stellar nurseries from the harsh radiation of the wider cosmos. This wall of darkness is not an obstacle. It is the very cradle of future light, a reminder that clarity is not always the goal, and that within the obscuring veil, the greatest works of creation are often undertaken in quiet solitude. The galaxy does not reveal its heart easily. It guards its creative core behind a veil of dust, teaching us that the brightest truths are often found by peering into the darkness. Peering through this dust with infrared and radio telescopes, we find another marvel, the central molecular zone. This is a region spanning the innermost few hundred light years of the galaxy, and it contains an astonishing concentration of dense, turbulent molecular gas. Perhaps 10% of all the molecular gas in the entire Milky Way is packed into this tiny central volume. It is a place of extreme conditions. The gas is hotter, denser, and far more turbulent than anywhere else in our quiet solar neighborhood. It is the galaxy's alchemical workshop, a dense, chaotic laboratory where the fundamental ingredients of stars, planets, and perhaps life itself are being forged in a fiery crucible. And rising perpendicular to the plane of the galaxy, stretching up and down from this central zone, are two colossal structures known as the Fermi bubbles. These are two enormous lobes of gamma-ray and X-ray emitting gas extending some 25,000 light-years above and below the galactic center, forming the shape like a giant goosely amber glass. Their origin is one of the biggest mysteries in modern astrophysics. They are the spectral remains of a truly enormous outburst of energy from the galactic center that must have occurred a few million years ago. Perhaps our sleeping giant, Sagittarius A star, awoke for a brief period, consuming a massive gas cloud or a star cluster and unleashing two stupendous jets of energy. Or perhaps it was a firestorm of star formation, a starburst that blew the galactic superwind, inflating these ghostly bubbles. Whatever their cause, they are a sign of our galaxy's dramatic and violent past, a faint, high-energy echo of a time when the heart of the Milky Way was not sleeping, but roaring with unimaginable power. We live in the quiet aftermath of a great storm, the faint, glowing shells of its power still expanding around us, a silent monument to the untamed energy that slumbers at the heart of our home.
Let us now expand our perspective to consider the very air we breathe and its improbable journey across the stars. A significant fraction of the heavier elements on Earth, the calcium in your bones, the iron in your blood, did not originate in our solar system's parent nebula alone. Our galaxy is awash with what astronomers call high-velocity clouds. These are vast, continent-sized agglomerations of gas, primarily hydrogen and helium, but laced with heavier elements, that move at speeds completely at odds with the galaxy's rotation. Many of them are raining down upon the Milky Way's disk from the intergalactic medium, primordial gas that is being drawn into our galaxy for the first time. But some, like the enigmatic Smith cloud, are on a boomerang trajectory. This colossal cloud was likely ejected from our own galaxy millions of years ago, perhaps by a cluster of supernova, and now its journey is reversing. It is falling back toward the galactic disk and is predicted to collide with it in about 30 million years, setting off a spectacular burst of star formation when it does. It is a beautiful thought that the very substance of our galaxy is not static, but is on a perpetual journey of departure and return, a cosmic breath that enriches the future with the substance of the past. The stars themselves are not all of one kind, nor of one origin. Our galaxy is a composite creation, a blend of stars born within it and stars that were born elsewhere and later joined. By analyzing the precise chemical fingerprints and orbital paths of millions of stars, astronomers can perform a kind of galactic archaeology. They have identified numerous stellar groups, acted components that move together in coherent streams and share a common unique chemistry. These are the dissolved remnants of the dwarf galaxies and star clusters that the Milky Way has consumed over its long history. One such event, the collision with the Gaia Enceladus galaxy mentioned earlier, was so significant that a large fraction of the stars in the inner halo of our galaxy are not native Milky Way stars, but are immigrants from this other, now vanished galaxy. You can look up at the night sky, and many of the faint stars you see are not original citizens of our home, but newcomers whose own island universe was long ago merged with our own. The starry sky is a grand assembly of different cultures and histories, a celestial melting pot whose quiet light tells a story of migration, of union, and of the creation of a new blended family. And this process of immigration is not over. The Milky Way is currently in the process of tidally stripping its largest satellite galaxy, the Large Magellanic Cloud. This companion galaxy, visible as a faint cloud-like patch in the southern hemisphere's sky, is on a collision course with our own. But the timeline is vast. The interaction has already begun. A long, tenuous bridge of hydrogen gas called the Magellanic Stream has been pulled from it, and its smaller companion, stretching across more than 100 degrees of the sky. In about 2.4 billion years, according to current models by Dr. Cadden and his team, the Large Magellanic Cloud is predicted to make its final plunging merger with the Milky Way. This future collision will be a monumental event. It will trigger a vast wave of star formation, potentially send our own solar system into a different region of the galaxy, and it will likely reawaken our slumbering central black hole, Sagittarius A star, feeding it with a torrent of fresh gas and turning it into a brilliant active galactic nucleus for a time. The serene night sky we know is not a permanent state. It is a fleeting moment of peace before a slow, majestic, and transformative storm that is already gathering on our cosmic horizon. Even the galaxy's rotation holds a profound secret. It doesn't spin like a rigid, solid object. It exhibits differential rotation, meaning that stars and gas at different distances from the center complete their orbits in different amounts of time. Our Sun, at its distance, takes about 230 million years. A star closer to the center might take only a few million. A star farther out takes much longer. This has a strange and beautiful consequence for the shapes of interstellar clouds and nebulae. Over millions of years, this differential rotation will stretch and shear any large structure. a vast spherical cloud of gas will be pulled and twisted, drawn out into a long, graceful filament. This is one of the forces that helps create the delicate, wispy, and often chaotic shapes we see in nebula. The galaxy's own motion is a grand, slow-motion sculpture, constantly reshaping the raw material between the stars into new and elegant forms. The universe is an artist that works in scales of time we can barely comprehend, using the gentle, inexorable turning of the galaxy itself as its chisel. Let us consider, too, the end of this grand structure. While the Milky Way is growing by consuming smaller galaxies, it is itself on a collision course with a much larger one, the Andromeda Galaxy. Andromeda is the closest major galaxy to our own, about 2.5 million light-years away, and it is hurtling towards us at a speed of over 100 kilometers per second. Unlike the slow merger with the Magellanic Cloud, this will be a collision of titans. In about 4.5 billion years, the two galaxies will begin to pass through each other. Individual stars are so far apart that very few will actually collide, but the immense gravitational forces will completely disrupt both galaxies. Their beautiful spiral structures will be destroyed, and long tidal tails of stars and gas will be flung out into space. After several passes over hundreds of millions of years, they will eventually settle and merge, coalescing into a single, vast elliptical galaxy, a new, more chaotic and spherical home for the combined stellar populations. Astronomers have already given this future galaxy a name, Milky Way. Our distant descendants may look up at a night sky utterly alien to our own, a sky dominated not by a graceful milky river, but by the dense golden glow of a new and larger stellar metropolis, born from the union of two ancient islands of light.
Thinking now of our own specific location, our sun resides in a rather special place. We are currently passing through a region known as the local interstellar cloud, a slightly denser, warmer puff of gas about 30 light-years across. But this cloud itself is just a small wisp on the edge of a much, much larger structure, a colossal empty cavern in the interstellar medium called the local bubble. This is a vast peanut-shaped region of space, at least 300 light-years long, where the density of gas and dust is abnormally low and the temperature is incredibly high, about 1,000,000 degrees. We're floating inside this immense, hot, empty void. The local bubble is thought to have been carved out by a series of about 15 to 20 supernova explosions that occurred in a nearby moving group of stars between 10 and 20 million years ago. These successive shock waves acted like a cosmic snowplow, sweeping the surrounding interstellar gas and dust outwards, creating this hollowed-out cavity. The sun just happened to wander into this bubble by chance about 5 million years ago. The very emptiness of our neighborhood is the ancient, expanding echo of a series of stellar deaths that occurred long before humans walked the Earth. The profound quiet of our stellar backyard is not a given. It is a temporary clearing in the cosmic forest, a silent space carved out by the ghosts of long-dead suns. And in this local neighborhood, there are other, more solid ghosts. In 2019, a team led by astronomer L.A. Cieza announced the discovery of what appears to be a protoplanetary disk, a ring of gas and dust where planets form, orbiting not a young star, but an ancient dying one, a white dwarf. This is an extraordinary and unexpected finding. White dwarfs are the small, dense, cooling embers of sun-like stars that have exhausted their nuclear fuel. The process of a star becoming a white dwarf is violent. It swells into a red giant first, which should destroy any nearby planets and their dusty disks. The existence of this disk suggests that planetary systems can somehow survive this ordeal, or perhaps reform from the debris of destroyed planets and asteroids. It is a tantalizing hint that even after a star has died,
the process of world building might begin anew in the twilight of its long life. It is planetary science in a graveyard, a second spring for a dying sun. Even in the ashes of a stellar furnace, the universe retains the memory of creation, the instinct to gather dust and dream of worlds yet to be. Let us contemplate the true scale of our galaxy's brilliance. If you could somehow travel far outside the Milky Way and look back at it, its total, absolute brightness is staggering. It shines with the light of roughly 20 billion suns like our own. However, a significant portion of this light never reaches us here on the inside or anywhere else. It is absorbed and scattered by the vast quantities of interstellar dust that permeate the galactic disk. For every 5 photons of visible light emitted by all the stars in the Milky Way, it is estimated that at least 1, and perhaps more, is absorbed by dust before it can escape the galaxy. This trapped energy doesn't just vanish, it gently warms the dust grains, which then re-radiate the energy away at much longer, far infrared wavelengths. In essence, the galaxy is glowing with a hidden, invisible light. When we look at the Milky Way with infrared telescopes, these dark, dusty lanes that obscure our view in visible light, they blaze with a soft, radiant warmth. The galaxy has a secret fire, a gentle, hidden luminosity that reveals itself only when we learn to see beyond the visible, to perceive the quiet warmth that lies hidden in the dust-filled shadows. And the distribution of life's essential ingredients is also a story written on a galactic scale. The abundance of elements heavier than hydrogen and helium, which astronomers collectively call metals, is not uniform throughout the Milky Way. There's a distinct metallicity gradient. Stars and gas clouds in the central regions of the galaxy are significantly richer in these heavy elements than those in the outer regions. This makes sense. Star formation has been happening furiously in the dense, active core, so there have been more generations of stars living, forging heavy elements, and dying to enrich the interstellar medium. Our sun is in a sweet spot. We are far enough out that we are not threatened by the intense radiation and frequent supernovae of the galactic core, but we are close enough in that our parent nebula was rich enough in heavy elements to form rocky planets like Earth. This has led to the concept of a galactic habitable zone, a ring within the galaxy not too close to the center and not too far out, where the conditions for the emergence of complex life might be most favorable. Our existence is a function of our address, a fortunate placement in a celestial neighborhood that is neither too violent nor too barren, but just right for the quiet chemistry of life to unfold. And what of the galaxy's future beyond its merger with Andromeda? The very long-term fate of what will be Milkomeda is one of gentle, inexorable decay. After the merger, the combined gas reserves will fuel a final spectacular burst of star formation that will last for 1 billion years or so. But once that gas is used up, the fire will go out. No new stars will be born. The galaxy will grow older and redder. The brilliant, massive blue and white stars will die off first, followed by the yellow suns like our own. Over trillions upon trillions of years, the only stars left will be the smallest, faintest, longest-lived red dwarfs. The great elliptical galaxy will fade from a brilliant gold to a dim, ruddy ember. Eventually, even these will exhaust their fuel and become black dwarfs, cold, dead cinders. And over even more unimaginable timescales, the orbits of these stellar remnants will decay through gravitational radiation, and one by one, they will slowly spiral into the supermassive black hole at the center until the galaxy is nothing but a single dark object, adrift and alone in an expanding, empty universe. Every star, every galaxy, every structure we see is but a fleeting arrangement in the long story of time, a beautiful temporary bonfire in the quiet gathering dark. Let this thought not be a source of sorrow, but a reason to cherish the immense, brilliant, and living moment of the now. Let us now turn ourselves around and face the other way. We spend so much time gazing inward toward the brilliant, crowded heart of our galaxy, but what is there to see when we look outwards, away from the center, toward the lonely rim? This direction is known as the galactic anti-center. The view here is profoundly different. The river of the Milky Way is thinner, fainter. The stars are fewer and farther between. Here, the dark lanes of dust are not hiding a brilliant core, but opening up windows onto the true, deep blackness of intergalactic space. It is a more subtle and stark beauty, a quiet vista of sparse stellar fields and the faint, ghostly smudges of distant galaxies, no longer lost in the glare of our own. In this direction lies the constellation Auriga, and when you look toward it, you are looking straight out the front door of our spiral arm, toward the cosmic wilderness beyond our city of stars. It is a humbling perspective, a reminder that our brilliant home is an island, and that in every direction lies a shore, beyond which extends an ocean of profound and silent emptiness. And yet, this emptiness is not truly empty, and it is traversed by messengers we can barely perceive. Our galaxy is glowing not only with light, but with a constant, silent flux of neutrinos. These are fundamental particles, often called ghost particles, for they have almost no mass and no electric charge. They interact so weakly with other matter that a neutrino born in the fiery heart of a distant supernova can travel through the entire width of the galaxy, through stars, through planets, through you, without ever being stopped or deflected. They are perfect messengers of cataclysm. Deep beneath the Antarctic ice, a vast telescope named IceCube uses a cubic kilometer of pristine, clear ice as its detector. Its sensors looking downward through the entire Earth to use the planet as a filter, allowing them to spot the faint flashes of light that occur when a high-energy neutrino from the northern sky finally, randomly, interacts with an atom of ice. It has seen neutrinos that have come from the direction of our own galactic plane, ghostly whispers from the most violent events in our home, carrying their secrets on a journey that nothing can impede. The universe sends its most intimate and violent stories not in a roar of light, but in the most insubstantial and silent of messengers. A truth that can only be captured by listening from the deepest, quietest place on earth. Let us now return ourselves to the grand shape of our home, that beautiful, gentle warp in the galactic disk. It is not a fixed, static feature. It is dynamic. It is moving. The entire warped structure is slowly precessing or wobbling around the center of the galaxy, much like a spinning top wobbles as it slows down. This is a slow, majestic, rhythmic oscillation, a ripple that itself is revolving. The calculations of astronomers like Dr. Krobevaka and Dr. Lopez Corredoira suggest that the line where the warp is most pronounced completes a full circle around the galactic center roughly every 600 to 700 million years. The great wave that lifts the stars up and pushes them down is itself a wave that is turning through space. It is a complex, three-dimensional dance, a slow, gravitational rhythm that our solar system passes through as we make our own grand orbit. The galaxy not only spins, it sways.
There is a hidden tempo to the cosmos, a deep and patient cadence written in the slow wobble of 100 billion suns. The vast spaces between the stars are home to a surprisingly complex and dynamic environment, a kind of galactic weather system. The interstellar medium exists in a delicate balance of different phases. Much like water can be ice, liquid, or steam, there is the hot ionized medium, a tenuous million-degree gas of charged particles heated by the shock waves from supernovae that fills vast volumes like the local bubble. Then there is the warm, neutral medium, uncharged gas at a few thousand degrees, which makes up a large part of the galactic disk. And finally, there is the cold, neutral medium, dense, frigid clouds of neutral atoms and molecules, where temperatures plummet to near absolute zero, and where new stars are born. These phases are in constant dynamic exchange. A supernova can flash heat a cold cloud into the hot phase, while the hot gas can slowly cool and condense, raining down to form the warm and eventually the cold phases. The entire galaxy is a self-regulating climate system, a place of winds and pressures and cosmic seasons. The galaxy is not a static place, but a living ecosystem in which the conditions for creation are born from a constant, beautiful, and necessary cycle of transformation between fire and frost.
Within our own stellar neighborhood, a feature of such immense scale and significance has been discovered so recently that it is redrawing the very maps of our galactic home. For generations, we believed our sun was part of a small, branching structure called the Gould Belt. But a new understanding, born from incredibly precise measurements of distance and motion, has revealed something far grander. Stretching for 9,000 light years, there is a long, thin, undulating wave of interconnected stellar nurseries, a vast, sinuous filament of gas and dust that is the most massive and coherent structure of its kind ever observed. It has been named the Radcliffe Wave. It is a gigantic, undulating spine of creation, rising and falling as it winds its way through our local region of the galaxy. Our own sun is located just 500 light-years from its crest, and we are currently moving away from it. This is not a spiral arm itself, but a grand foundational feature within an arm, like a great river on a continent. We thought we lived in a quiet suburb of the galaxy, only to find we reside just off the shore of a vast continent-spanning wave of creation, a testament to the fact that our own home is still a land of undiscovered wonders. And drifting silently within this grand architecture, in the dark spaces between the arms and even within them, is a population of worlds we can never truly see. These are the rogue planets, or orphaned worlds, planets that do not orbit a star. They were likely formed in solar systems much like our own, but were ejected during the chaotic gravitational dance of their early history, flung out into the galaxy to wander forever in the cold and the dark. We cannot see them, for they have no parent star to illuminate them. We could only detect them fleetingly through the rare chance of a gravitational microlensing event, where a rogue planet passes precisely in front of a distant star, its gravity briefly magnifying the star's light. Based on these few chance detections, astronomers now believe that the Milky Way could be teeming with them, that there may be billions, perhaps even trillions of these solitary wanderers, potentially outnumbering the stars themselves. There are worlds without a sunrise, forever adrift on a sea of silent, star-dusted night. For every world bathed in the warmth of a sun, there may be a dozen more that carry only the memory of light, on a lonely pilgrimage through the infinite dark. And just as there is a population of lost worlds, there is a theorized population of lost suns, a hidden graveyard that underpins the living galaxy. When the very first most massive stars in the Milky Way died billions of years ago, they collapsed into neutron stars and black holes. Over the eons, gravitational interactions would have gently nudged these dark, compact remnants, causing them to slowly sink and settle into a flattened, dense configuration deep within the galactic plane, even denser and flatter than the visible disk of stars we see. This proposed structure is known as the galactic underworld. It is a vast, invisible necropolis, a silent, spinning disk composed entirely of the dead. Its total mass could be as much as 1% of the entire galaxies, a hidden foundation of immense density, its presence detectable only by the subtle gravitational pull it exerts on the stars that live and shine above it. Beneath the luminous, vibrant city of light, there lies a quiet, invisible city of endings, a silent testament to the countless generations of fire that had to burn and die to create the home we know. And even in the living, breathing gas that fuels new stars, the galaxy shows a subtle, beautiful defiance of perfect order. When we map the distribution of different molecules in the interstellar medium, we find curious asymmetries. For instance, clouds of carbon monoxide, a key tracer of the cold gas that forms stars, are not distributed in a perfectly smooth, symmetrical pattern on either side of the galactic center. There are regions where it is more clumpy, more concentrated, or arranged in different patterns than its mirror image on the other side of the galaxy. This is not a flaw, it is the galaxy's character. It suggests a history of localized events, a supernova here, a stellar wind there, a past collision, all of which have stirred the interstellar medium in unique and unpredictable ways. The galaxy is not a perfect machine-like object. It is a complex, evolving entity with a memory, its very composition telling a lumpy, imperfect, and far more interesting story than any simple model could predict. The universe does not paint with perfect strokes of symmetry. It prefers the beautiful, unpredictable character that comes from a long and eventful life, a story written in the subtle imbalances of stardust.
Let us adjust our perspective now, not outwards or inwards, but to our own particular orientation, our place upon this grand spinning stage. The plane of our solar system, the flat disk in which all the planets orbit our sun, known as the ecliptic, is not aligned with the great plane of the Milky Way. It is tilted, inclined at a steep angle of about 63 degrees. Imagine our galaxy is a vast, flat record on a turntable. Our solar system is not spinning parallel to it, but is instead like a small, tilted gyroscope making its own way around the larger disk. This has a wonderful consequence for our journey. As we orbit the galactic center, we are not confined to the mid-plane. We are on an undulating path that carries us up and down, like a horse on a cosmic carousel. We are currently above the densest part of the plane, but our orbit will carry us down through it, and then up and out the other side in a slow, gentle oscillation that takes tens of millions of years to complete. Some scientists, like Michael Rampino, have speculated, though it remains an unproven hypothesis, that these passages through the dense, dusty, and gravitationally disruptive midplane might correlate with periods of geological change on our own world. Our path through the cosmos is not a simple, flat circle. It is a three-dimensional wave, a gentle, rhythmic rising and falling through the river of stars. And our galaxy is not a silent, rigid structure. It responds to touch. It rings. Just as a bell vibrates when struck, the disk of the Milky Way vibrates with immense slow-motion waves in response to gravitational disturbances. This is the field of galactoseismology. When a small dwarf galaxy or a massive dark matter halo plunges through the galactic disk, it doesn't just punch a hole, it sends ripples spreading outwards.
These are not ripples of water, but coordinated vertical oscillations of the stars themselves. Vast swaths of the galaxy, billions of stars together, will gently move up and then down out of the galactic plane in a coherent wave-like motion. Using precise data from satellites that map the positions and velocities of stars, astronomers can see these subtle vertical waves frozen in time, a pattern of stellar corrugations across the disk. We can see the aftermath of an impact that may have happened hundreds of millions of years ago. The galaxy is still ringing with the memory of that encounter. The great disk of stars is a living instrument, its surface a testament to its history, forever resonating with the silent, gravitational music of past encounters. Let us return to the galaxy's great engine room, the luminous central bar. This immense river of stars is not spinning in isolation. It is deeply connected to the invisible structures that surround it. And according to detailed computer simulations and observations of stellar motions, a fascinating process is unfolding. The bar appears to be slowing down. This is not because it is running out of energy, but because it is giving its energy away. The bar is rotating within the vast spherical halo of dark matter. As it spins, its immense gravity creates a wake in the dark matter, a slight overdensity that trails behind it. This wake of invisible matter then exerts its own gravitational pull back on the bar, a gentle, persistent tug that acts like a brake. It is a profound and subtle exchange of angular momentum between the visible matter we can see and the dark matter we cannot. The very heart of our galaxy is in a slow, gravitational conversation with its own invisible shroud. Even the most powerful structures are shaped by the quietest forces. The luminous engine of the galaxy, slowly yielding its momentum to the immense, silent sea of darkness it inhabits. And in the vast, cold spaces between the suns, where we once imagined only simple atoms and dust, the universe builds with an unexpected and breathtaking elegance. Astronomers studying the faint infrared glow of the interstellar medium have discovered the presence of one of nature's most perfect shapes, Buckminster fullerene. These are molecules, also known as buckyballs, made of 60 carbon atoms arranged in a hollow sphere, a structure exactly like a soccer ball. These tiny, intricate, and highly stable carbon cages have been found floating in the diffuse gas between the stars and in the colorful expanding shells of dying suns known as planetary nebulae. How these perfectly symmetrical, complex structures form in the chaotic, low-density environment of space is a beautiful puzzle. A testament to the laws of chemistry and physics are capable of producing profound order and complexity, even without the warmth of a sun or the crucible of a planet. The cosmos is a master architect at every scale, finding ways to build perfect, intricate spheres of atoms to drift silently alongside the perfect colossal spheres of burning stars.
Let us now consider the very substance of rarity, the gleam of gold, the heft of platinum, elements that our world holds as precious. Their origin story is not written in the heart of ordinary suns like our own, nor even in the fiery death of a typical massive star. Their forge is an event of almost unimaginable violence and rarity, a kilonova. This cosmic alchemy begins with two neutron stars, the incredibly dense, city-sized corpses of giant stars locked in a decaying orbit. For millions of years, they spiral closer and closer until they finally touch.
The resulting collision is a cataclysm that rips the very fabric of space-time and for a few fleeting moments creates a crucible of such extreme pressure and temperature that the laws of physics are pushed to their limits. In this maelstrom of neutron-rich debris, the heaviest elements in the universe are born, forged in a flash of gravitational waves and gamma rays, and then flung outwards to seed the surrounding interstellar clouds. A single one of these neutron star mergers can produce many Earth masses of gold and platinum, scattering it like a fine, glittering dust across thousands of light years. The most enduring symbols of value and beauty on our quiet world were born in the most violent and ephemeral of cosmic embraces, a treasure created in a shattering instant and then gifted to the ages. And as we peer back toward the galaxy's brilliant core, the shape it reveals is more complex and more beautiful than a simple bar or sphere. If you could see the central bulge of our galaxy from the side, you would not see a flat, horizontal structure. Instead, the stars within it trace out a remarkable form, a shape that resembles a giant X or the shell of a peanut. This is not a solid object, but the result of the collective orbits of billions of stars. The stars that make up the central bar are not moving in simple, flat ellipses. Many of them are following complex, resonant orbits that carry them high above the galactic plane and then swoop them down far below it. This synchronized, oscillating motion, when viewed from the side, creates this three-dimensional buckled structure. It is an emergent property of gravity and rotation, a self-organized pattern of immense scale sculpted by the silent music of orbital mechanics. The very heart of our stellar home is not a simple shape, but a dynamic, multi-layered sculpture, a testament to the elegant and surprising forms that are born from the intricate dance of a billion stars. And in this same central region lies a deep and persistent puzzle, a faint and mysterious glow for which we have no certain explanation. When we observe the area around the galactic center in microwave frequencies, there is a diffuse, spherical haze of energy that seems to permeate the region, a soft, warm fog that is brighter than it should be. It does not come from any known celestial objects or processes. It is not the light of stars, nor the heat of dust, nor the radiation from hot gas. It is an excess, a ghost in the galactic machine. One of the more exotic and entirely unproven ideas proposed by researchers is that this haze could be the faint signal of dark matter particles annihilating each other. This is purely speculative, a fascinating hypothesis awaiting any form of proof. For now, the haze remains an enigma, a quiet, unexplained signal from the most crowded and chaotic part of our galaxy. Our home holds its deepest secrets close to its heart, whispering in a language of faint, pervasive energy that we have heard but do not yet understand. And let us end this part of our journey with a familiar, gentle phenomenon, twinkling. The stars in our sky twinkle because their tiny points of light are distorted as they pass through the turbulent layers of Earth's atmosphere. The galaxy, it turns out, has its own version of this effect on a scale that is almost beyond imagining. The interstellar medium, the thin gas and plasma that fills the space between the stars, is not perfectly smooth. It is a turbulent, clumpy medium full of swirling eddies and dense filaments. When radio waves from a very compact and distant object, like a spinning pulsar, travel through this medium on their long journey to us, they are bent and scattered by these irregularities. This causes the radio signal to fluctuate in intensity. It scintillates, it twinkles, not in visible light, but in the radio part of the spectrum. This interstellar scintillation is a powerful tool, allowing astronomers to probe the structure of the invisible gas between the stars. But it is also a beautiful thought. The galaxy itself has a celestial atmosphere, a tenuous, invisible veil that imparts a gentle, rhythmic flicker to the most ancient and distant voices, a final, subtle touch added to the light from across the cosmos.
Let us now drift into the dust itself, the fine, dark powder that veils the stars and serves as the raw material for new worlds. It is not a simple, uniform substance. It is a complex and beautiful collection of tiny, intricate grains, each one a story in miniature. A significant component of this dust is made of polycyclic aromatic hydrocarbons, or pHs, vast, flat molecules of cosmic soot formed in the cooling atmospheres of carbon-rich stars. There are also infinitesimal grains of crystalline sand, silicates, forged in the hearts of dying suns and blown out into the void. And coating many of these grains, especially in the coldest, darkest clouds, is a delicate frost, a mantle of frozen water, ammonia, and methane. So when you look at a dark nebula, you are seeing the collected smoke, sand, and frost of a billion stellar lifetimes, the very same materials that, a few billion years ago, coalesced to form the ground beneath your feet, the water in your oceans, and the very air in your lungs. The galaxy is a grand act of recycling, where the ashes of one generation of stars become the delicate foundational dust from which the next generation of life is built. The spinning of the galaxy is not a smooth and featureless force. It has a rhythm, a pulse, and this creates zones of gravitational harmony and dissonance. These are known as Lindblad resonances. Imagine them as cosmic grooves, specific orbital distances from the galactic center where a star's natural orbital frequency synchronizes perfectly with the gravitational influence of the spiral arms or the central bar. Stars whose orbits fall into these resonant zones can have their paths stabilized. They are gently nudged and shepherded by the larger galactic structure. There is a particularly special place, the co-rotation circle, an orbit where stars move at the exact same speed as the spiral density wave itself. A star born there could, in theory, remain within the same spiral arm for its entire life, a resident of a single celestial neighborhood rather than a transient traveler passing through. The galaxy has its own hidden geography of stability, quiet eddies and safe harbors in the great celestial river, where the rhythms of the small and the great fall into perfect, silent step. While the grand motion of the galaxy is one of majestic, inward spiraling rotation, there are exceptions, currents that flow against the tide. One of the most curious of these is a structure known as the Far 3 kiloparsec arm. This is a spiral arm located relatively close to the galactic center, but unlike the others, its gas appears to be expanding, moving outwards, away from the core at a speed of over 50 kilometers per second. This contrary motion is a profound puzzle. The most plausible explanation, according to models by various astrophysicists, is that the gas in this arm is not on a simple circular path, but is following the lead of the highly elongated non-circular orbits of the stars in the great central bar, which can swing it outwards for a portion of its journey. It is a river of gas flowing, for a time, upstream. A powerful and beautiful signature of the galaxy's complex inner dynamics. Even in a system governed by the most fundamental forces, there is room for rebellion, for a gentle, contrary current that reminds us the cosmos is never as simple as it first appears. The galaxy's gravity is not just a force that holds our sun in a grand orbit. It is a force that reaches deep into our own solar system, to its most distant and lonely frontiers. Far beyond the planets lies the Oort cloud, a vast,
theoretical sphere of trillions of icy cometary bodies encircling our Sun at a distance of up to a light year or more. At this immense distance, the Sun's gravitational grip is incredibly tenuous. The single most significant and persistent gravitational influence on these sleeping comets is not a passing star, but the vertical tide of the Milky Way itself. As our solar system oscillates up and down through the galactic plane, the gentle but inexorable pull from the mass of the galactic disk subtly perturbs the Oort cloud, stirs it, gently nudges these icy bodies. It is this galactic tide that is thought to be the primary mechanism for dislodging a comet from its billion-year slumber and sending it on its long, silent fall toward the inner solar system, where it may one day grace our skies. The arrival of a silent and graceful comet in our heavens is often a message from the galaxy itself, a gentle gravitational nudge delivered from across 100,000 light-years, a quiet hello from the great sea of stars in which we float.
Let us now dissolve the very idea of a single unified moment, for in a structure as vast as our galaxy, there is no such thing as now. The Milky Way is 100,000 light-years from one edge to the other, which means that light, the fastest messenger in the universe, takes 100,000 years to make that journey. Imagine a brilliant, massive star erupting in a supernova on the far rim of the Perseus Arm. As its light begins its long pilgrimage across the void, the other side of the galaxy, in the Norma Arm, will know nothing of it. For 10,000 years, for 50,000 years, for 99,999 years, that entire half of the galaxy will exist in a reality where that star still shines peacefully. The galaxy is not a single coherent entity existing in one moment. It is a vast mosaic of different times, causally disconnected from itself. The galactic core we see tonight is the core as it was 27,000 years ago. A star we see 50,000 light-years away is an echo of a time before recorded human history. The galaxy lives in a beautifully shattered present, a chorus of 100 billion pasts, all singing to us in the same instant, teaching us a profound and gentle patience, for the universe unfolds not at the speed of thought, but at the quiet, unhurried pace of light. And in that ancient light, the stars carry their own birth certificates, a story of their age written in a language of atomic decay. This is the science of nucleocosmochronology. When a supernova explodes, it forges not only stable elements like gold or iron, but also radioactive isotopes such as thorium-232 or uranium-238. These unstable elements are flung out into the interstellar medium and become incorporated into the next generation of stars. And from the moment they are created, they begin to decay, their atoms transforming at a precise and unchangeable rate, like a perfect celestial clock. By measuring the faint spectral signature of these radioactive elements in the atmosphere of a very old metal-poor star, and comparing their abundance to a stable element forged in the same event, astronomers can calculate how long that atomic clock has been ticking. They can, in essence, listen to the faint radioactive chime of the star's formation, and from that, they can date the star with astonishing precision, and by extension, place a lower limit on the age of the universe itself. Every ancient sun is a timekeeper, its light a delicate spectral message carrying not only the story of its fire, but the precise ticking memory of the moment it was first kindled. As we look toward the outer edges of our home, out past our own spiral arm, the map grows faint and the lands are still being discovered. There, in the direction of the constellation Monoceros, lies a vast and enigmatic structure, a great looping river of stars known as the Monoceros Ring. It is an immense diffuse band of suns that encircles the entire Milky Way, containing the mass of hundreds of millions of stars, yet it does not seem to belong to any of the known major structures of our galaxy. Its nature is the subject of a deep and beautiful debate.
Some astronomers believe it is not a separate entity at all, but a grand optical illusion, a complex ripple or corrugation in the flared, warped outer disk of our own Milky Way. But another, more romantic possibility is that we are looking at a crime scene, that this great ring is the ghostly, shredded corpse of a dwarf galaxy torn apart by our own galaxy's tides and now smeared into a stellar stream so vast that it wraps around our home like a celestial serpent. Our galaxy is still a place of mystery and illusion, where the faint light from the farthest shores may be a reflection of our own home or the beautiful, lingering ghost of a world that once was. And in this grand, interconnected system, the possibility of connection may be deeper than just gravity and light. One of the most intriguing, though entirely unproven hypotheses is called lithopanspermia, the idea that life itself can travel between the stars, shielded within rock. Imagine a world teeming with microbial life struck by a large asteroid. The impact could be so powerful that it ejects tons of rock from the planet's surface with enough force to escape its star's gravity entirely. These fragments would be sent tumbling into interstellar space. Deep within the core of these rocks, microbes could be shielded from the vacuum and the harsh cosmic radiation. They would enter a state of deep suspended animation, drifting in the cold and in the dark for millions, perhaps tens of millions of years. Eventually, by an almost impossible chance, one of these life-bearing vessels might be captured by the gravity of another star and fall upon a new hospitable world, a silent, patient seed delivered across the unimaginable void. It is a wondrous thought, to be held gently as you drift, that the galaxy may be connected by a hidden biological web, a slow, patient exchange of possibility, whispered not in light, but carried in the silent, stony hearts of wandering worlds.
Let us now contemplate the very sound of silence, the background hum of the cosmos, which our galaxy helps to shape. The universe is filled with a faint, ever-present sea of gravitational waves, ripples in the fabric of space-time itself. These are not from single, recent events, but are the combined, overlapping echoes of every pair of supermassive black holes that have ever merged, anywhere in the universe, over all of cosmic time. This creates a stochastic gravitational wave background, a gentle cosmic static. Our own Milky Way contributes to this chorus. Orbiting our central black hole, Sagittarius A star, are likely many smaller, stellar mass black holes. As they orbit, they radiate gravitational waves, adding their own quiet local hum to this universal background. And when our galaxy eventually merges with Andromeda, the dance of their two supermassive black holes will create a crescendo of gravitational waves, a powerful song that will ripple outwards, adding a new and thunderous core to the background music of the cosmos for billions of years to come. The universe has a memory of every ancient violent dance, and our own home is both a quiet contributor and a future soloist in this silent, eternal symphony of space-time. And in the fine, dark dust that drifts between the stars, we find a curious and beautiful asymmetry. Life on Earth, in its most fundamental building blocks, amino acids and sugars, shows a distinct handedness. Molecules can exist in two forms that are mirror images of each other, like your left and right hands. For reasons we do not understand, life on our planet exclusively uses left-handed amino acids and right-handed sugars. The origin of this preference is one of the deepest mysteries in science. A tantalizing clue comes from the heart of our galaxy. When light from distant stars passes through interstellar dust clouds, it can become polarized. Its waves begin to vibrate in a preferred direction. Astronomers have discovered that in certain star-forming regions, like the Orion Nebula, this light is not just linearly polarized, but circularly polarized, twisted into a corkscrew shape.
This circularly polarized ultraviolet light has the ability to selectively destroy one-handedness of a molecule while leaving the other intact. It is a plausible, though not yet proven, idea that the raw ingredients of life were seeded with this preference long before our planet ever formed, a subtle galactic bias imparted by the twisted light of a stellar nursery. The most fundamental and intimate asymmetry of our own biology may have been born in the interstellar dark, a choice made not by evolution, but by the gentle, spiraling touch of starlight on dust. Let us consider the grandest migration in our galaxy, not of stars, but of the very ground on which they stand. The concept of galactic tides has a profound implication. The differential rotation of the galaxy means that stars closer to the center orbit faster than stars farther out. This means that over billions of years, a star does not remain in the same stellar neighborhood. Its galactic longitude is constantly changing. A star that formed from the same parent cloud as our Sun, a solar sibling, might now be on the complete opposite side of the galaxy. Our Sun itself, over its 4.6 billion year lifetime, has likely migrated a significant distance from where it was born, perhaps tens of thousands of light years. This process is called radial migration. It is not that the star is moving inwards or outwards on its own, but that its orbit is subtly altered by interactions with the spiral arms, causing it to hop from one near circular orbit to another, drifting slowly inwards or outwards over the eons. We are not natives of this particular stellar region. We are immigrants, our Sun having wandered far from its birthplace. The galaxy is a place of constant, gentle relocation, where no star truly has a fixed address, but is instead on a slow, multi-billion-year pilgrimage around the stellar city. And as we journey, we carry with us a shield, a protective bubble that is not of our world, but of our star. The Sun emits a constant stream of charged particles called the solar wind. This wind flows outwards at supersonic speeds, carving out a vast cavity in the interstellar medium called the heliosphere. This is our Sun's sphere of influence, its magnetic atmosphere. The edge of this bubble, the heliopause, is the boundary where the pressure of the outward-flowing solar wind finally balances with the pressure of the inward-pressing interstellar medium of the galaxy. This is the true edge of our solar system, and it is a dynamic and fluid frontier. As we move through the galaxy, the density and speed of the interstellar gas we are plowing through changes, and so the size and shape of our heliosphere changes in response. In denser clouds, it may shrink. In tenuous regions, it will expand. Our protective bubble breathes, inhaling and exhaling in response to the changing cosmic weather of the Milky Way on a timescale of thousands of years. We travel through the galaxy in our own vessel, a magnetic ship, whose very size and shape is in a constant, quiet dialogue with the great stellar ocean through which it sails.